Ionization energy means the minimum energy which is required to remove the electrons from its orbit is said to be the ionization energy. M(e to the power of 4 divided by 8 h cube epsilon naught square into C is considered as a constant and it is given by R. Minimum energy required to raise the electrons from its ground state, that is lower energy level, to a higher energy level is said to be excitation energy. Hello everyone, I am Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the last bit of the chapter, that is chapter 12, Atoms, and it is session 4. So in today's class, we are discussing about the frequency as well as the wave number of the electrons and the ionization energy, excitation energy, and the de Broglie's explanation on the Bohr's postulate. So let us begin with the frequency, that is frequency and wave number of the emitted radiation in hydrogen-like atom. So now we know that in hydrogen atom there are energy levels. Lowest energy levels, highest energy levels. Lowest energy level is nothing but the ground state, which is called as N is equal to 1. The energy levels is given by a numbers such as N1, N2, N3, it goes up till, correct? So now the electron is the one which makes the transition. So there is a transition of electron, that is when the electron jumps, that is excites to higher orbit from the lower stage, that is the ground stage, to a higher energy level. Later, due to its instability, what happens to the electron? It makes a transition from higher level to the lowest level. So suppose if this is a ground state, I'll just write it as G state, it's a ground state, and here there are higher energy levels. When the electron excites, this is the excitation of the electron from the ground state to a higher stage, and it resides there. When it loses its stability, what happens to the electron? It gets de-excited, that is there is a transition which is taking place from the higher energy level to the lower energy level. During this transition, there is liberation of photon. There is a liberation of photon. Suppose the energy of this state is E1 and this state is E2. So how is this photon given? Photon is given by the difference between E2 minus E1, that is difference between two energy levels. So this set of expression we have identified in Bohr's third postulate. Bohr's third postulate, which tells us that when an electron makes a transition from higher energy level to a lower energy level, it emits a photon which is equal to h nu Planck's constant into the frequency. It emits the photon which is equal to the difference in two energy levels, final energy as well as initial energy. So this set of equation is in our hands. Now what are we supposed to do? So we know the equation of energy which is given as, for E2 set of equation we have 1 divided by N2 square. Okay, and this is said to be negative because the equation of total energy as discussed in the previous session, that equation we are just applying over here. So into, we have Z square e to the power of 4 divided by 8 h square epsilon naught, and here it is m. This is one set of equations, so this is epsilon naught square. Okay, so next is minus of E1. Minus of E1 means this is the energy of the electron which is in the first orbit. So it can be written as 1 divided by N1 square into, it is again Z square e to the power of 4 m divided by 8 h square epsilon naught square. So now we are considering hydrogen atom. So Z becomes 1. So equation becomes minus 1 by N2 square M e to the power of 4 divided by 8H square epsilon naught square into minus of, this should be minus 1 by N square to M e to the power of 4 divided by 8H square epsilon naught square and bracket close. Now on summing up both, so it becomes minus and minus, you have plus. So we'll have to rearrange the terms. So our work is to rearrange the terms now. So let us continue with things. So what are we having now? H nu is equal to minus 1 by N2 square into M e to the power of 4 divided by 8 H square epsilon naught square. Bracket close. Minus and minus, it was plus, and 1 divided by N1 square into M e to the power of 4 divided by 8 H square epsilon naught square. On taking common out, we have M e to the power of 4 divided by 8 H square epsilon naught square into 1 by N1 square minus 1 by N2 square. This is the photon which is emitted. The energy is been fused over here. We have simplified the energies, initial as well as final energies. So this is a set of equation we have got. So we can consider the nu now, that is taking your H towards the other side. We have nu is equal to M e to the power of 4 8 H cube epsilon naught square into 1 by N1 square minus 1 by N2 square. So we know that nu is nothing but, that is a frequency is nothing but C divided by lambda. So in the place of nu, we can substitute C by lambda is equal to M e to the power of 4 divided by 8 H cube epsilon naught square into 1 by N12 minus N2 square. Okay, so we know that nu dash is a wave number. So wave number can be equated as 1 by lambda. So we have 1 by lambda into C. So this set of equation, that is the last set of equation, can be rewritten as nu dash is equal to 1 by lambda is the equation. So which becomes M e to the power of 4, I'm taking my C towards the other side, divided by 8 H cube epsilon naught square into C and 1 by N1 square minus N2 square. So M e to the power of 4 divided by 8 H cube epsilon naught square into C is considered as a constant and it is given by R. So this set of equation can be considered as R. So I can just rewrite the equation over here, say it as R is nothing but M e to the power of 4 divided by 8 H cube epsilon naught square into C is a constant. So equation, the wave numbers equation can be written as R into 1 divided by N1 square minus 1 divided by N2 square. So this is the frequency and wave number of emitted radiation in hydrogen. So that is all about this derivation. And next we have the excitation, that is during this excitation there is energy called as excitation energy as well as ionization energy. So as you see in the diagram, this is the energy level diagram, just for your reference to understand how exactly the energy level has been split up according to the shells. So here, the ionization energy. What is meant by ionization energy? Ionization means ionizing, removal. Okay, so removal of an electron over here. In order to remove an electron, we need certain energy. Okay, because electrons are bounded to a nucleus within certain attractive force. Okay, once the attractive force is there, it is very difficult to pull it out. So we need to exert certain energy on it in such a way that the electron can be easily pulled out. That is, electrons can be easily ionized. So what is meant by ionization energy? Ionization energy means the minimum energy which is required to remove the electrons from its orbit is said to be the ionization energy. So how will you define ionization energy? Ionization energy is the minimum energy which is required to remove the electron from the ground state of an atom to the higher energy level or which is at an infinite distance from the nucleus is said to be ionization energy. So that is the infinite symbol. So minimum energy which is required to remove the electron from a ground state of an atom to the infinite distance from the nucleus is said to be ionization energy. So that is all about your definition of ionization energy, which may be asked for 1 mark, and it is important concept. Okay. Next is excitation energy. Getting excited. We get excited when we just look into some surprises or some other favorite foodstuffs or favorite objects of us. So whenever we are so very surprised, we will tell that we are in an excited state. That is, we start jumping. So jumping is nothing but excitation. So what is this excitation energy? Jumping of electrons from a ground state to a higher state. So this is a ground state and this is a higher energy level. So what is this excitation energy? Excitation energy is minimum energy which is required to raise the electron. That is, in order to excite the electrons from the ground state to a higher energy state is said to be the excitation energy. So what is excitation energy? Minimum energy which is required to, this is if suppose this is an electron, required in order to excite the electrons to a higher energy level, then that energy is said to be excitation energy. This is also for 1 mark and it is very important. Okay. So minimum energy required to raise the electrons from its ground state, that is lower energy level, to a higher energy level is said to be excitation energy. So here ends ionization energy as well as excitation energy, which is just for 1 marks. Next, going on to the limitations of Bohr's model, which is also important. So you will have to note it down. Limitations of Bohr's model. You know what are the postulates given by Bohr? That is, he gave 3 postulates. In first postulate, it was like the electrons revolve around the nucleus in a stationary orbit, wherein that postulate was known as non-radiating postulate. So the radiations during the revolving of the electron was absent. Okay, and the second he gave the angular momentum of the revolving electron in the stationary orbit is equal to integral multiples of h by 2 pi, and third postulate what he gave was during its transition, that is electron's transition, it gives a photon, and the photon is nothing but the difference between the second energy as well as the first energy, that is initial and final energies. So here that was the postulates given by Bohr, and there was a limitations also in that postulate. So which was that? That limitation are listed below over here. The Bohr's explanation, it cannot explain the spectrum due to complex atoms. So the spectrum which is given by the complex atom is not at all explained in the Bohr's atomic model, with more electrons revolving around the nucleus. Okay, so it failed to explain the spectrum of the complex atoms. And the second point is, there was no information about intensity of each spectral line. What was the intensity of each and every spectral lines? No information about that. So there also Bohr field. And third one, it did not explain the filling up of electrons in each of the subshell. It is not that all the electrons arise only in one subshell. Okay, it is like each and every electrons are having different places. Like in deserts, only desert adapting animals live, and in cold places the animals which adapt to cold places, they live. Like that, each electron are getting adapted only to certain subshells. Okay, so it did not explain the filling up of electrons in the shells and subshells. So next, finally, we have, it cannot explain the splitting up of spectral lines in Zeeman effect and Stark effect. These were the set of points in order to observe, that is, limitations of Bohr's model. So after which we are having a last bit of this chapter, that is atoms, and it was nothing but de Broglie's explanation of Bohr's postulate. So, de Broglie's full name was Lise de Broglie. He gave, according to Bohr's second postulate, that is, he just took the Bohr's second postulate, which termed as the electron's angular momentum is integral multiples of h divided by 2 pi. Having this concept, Lise de Broglie, what did he do? He just matched up his concept with the Bohr's second postulate. So, the angular momentum of the electron, that is, there is a nucleus with charge Ze, and the electrons revolve around the nucleus in a circular orbit, and this distance is said to be r. Electron is having charge minus e, which moves in certain velocity v, and its mass is m. So this was a certain condition, that is the introductory part, like for us to understand how exactly the electron move in a stationary orbit. Now, what did de Broglie do? He just held the concept of Bohr's second postulate, which told that the angular momentum of the electron revolving around the nucleus is equal to the integral multiples of h by 2 pi, and it is said to be quantized. Quantized in the sense, integral multiples of this h by 2 pi. Okay? According to de Broglie, the electron which orbits in circular orbit must be seen as a particle wave. Okay? So, now we have Bohr's postulate equation given by L is equal to NH by 2 pi. And since L is equal to mvr, mass, velocity and radius, we have L, substitute in L, we have mvr is equal to NH by 2 pi. Okay, so this is said to be equation 1, and this is nothing but Bohr's condition. But according to de Broglie, what did he do? He told that the particle behaves as a wave. Which particle is it talking about? He considered the electron as a particle. So, electron revolves around the nucleus in a stationary orbit. So, there is no movement. This was told by Bohr. Correct. So, here we have a nucleus, and the electrons revolve around the nucleus. According to de Broglie, he told that it moves as a wave. So, electron move as a wave. So, this condition was given by de Broglie. The movement of the particle is like wave in nature. So, which is a particle? Electron is a particle. When electron is a particle, it itself moves as a wave around the nucleus. So, now we have to consider, suppose we just take a string where one end is fixed. And the wave, so if suppose this is the mean position, the wave is having a movement, wavy nature. Correct? And the rest other set of movement will be, which is given by this position. Okay, so here the wave which survives during this set of motion, that is, we know what is meant by wavelength, a length of a complete wave. So the complete wave is from here up till here. This set is said to be a complete wave. So then we can give this as wavelength, and this is represented as lambda. Okay, this is a complete wave. Now, the wave which survives during this process is nothing but the wave which forms at the node. Survival of the fittest. That is, the wave which is formed at the node. This position is said to be anti-node, and this position where it merges, where the two waves, one is the imaginary wave and the normal wave which moves, that is, it moves upside and down. So the point where it meets is said to be node, and the survival of the wave is only at the node. Okay, and the wavelength, thus the wavelength was given by lambda and it was fused with n, that is integral multiples of the wavelength. That is, waves which is formed over here are in the integral multiples, that is 1 lambda, from here to here it is 2 lambda, like that it keeps on going. Okay, so now we have n and lambda with us, which is known as integral multiple of wavelength. Now we consider the electron which is revolving around the nucleus with the radius r base n and with the speed v subscript n, that is, we are talking about the nth orbit. So our radius will be for nth orbit, velocity will be for nth orbit, and mass is a constant term. The mass is the only one which is said to be a constant. Okay, so now we will have to equate it as so the total wavelength which is over here, which is given by n lambda, is equal to, if you just take this wire and fold it, it gives you the circle. So it's a wave, the complete wave. Okay, so complete wave determines a circle. So what is the circumference of the circle? It is given by 2 pi r, and we are talking about the nth orbit, so it is Rn. So we have n lambda is equal to 2 pi r and n. And according to de Broglie equation, we have lambda is equal to h divided by p. So momentum is given as h divided by m into v subscript n, which is said to be lambda. And what is lambda? We have this equation where lambda is equal to 2 pi Rn divided by n, where this comes to the denominator. So 2 pi Rn divided by n is equal to h divided by m into Vn. Take your 2 pi to the other side and carry your mvr to the other side. So we have m v subscript n into r subscript n divided by n, which is equal to h divided by 2 pi. Take your n towards your right hand side. You have mvn into rn is equal to n into h divided by 2 pi. So this is the set of equation which you're having in your hands, that is de Broglie's explanation of Bohr's postulate. So mvr is equal to nh by 2 pi. Say it as equation 2. Holds good with the first equation, that is mvr is equal to nh by 2 pi. Here we are talking about the nth orbit. So both also are equated. So the electrons are said to be a particle wave according to de Broglie. So it is very obvious that this de Broglie has taken the second postulate of Bohr and have proved it, correct? So the electrons are having wavy nature. That was a concept explained by the de Broglie. So for here, our chapter 12 atom has come to an end. So in today's class, we have studied the frequency and wave number of an electron, excitation energy, ionization energy, and you have seen by the diagram the energy levels and limitations of Bohr's model was studied, and de Broglie, that is Leibniz de Broglie, had taken a concept of Bohr's second postulate and he has observed that electron is the one which behaves as a particle wave. So this was a concept in today's session. Let us all meet in the upcoming chapters in the next session. Until then, have a good day. Thank you.